Okay, uh, hello everyone. It's been a long time to upload a new video on this channel. So, in this video, uh, I'm going to show you what kind of called a new progress on this scanning electron microscope project. And in this video, I will show you a little bit tungsten wire and coated with gold. It's been smashed in a round shape, and what it used for is a contactor for a tectonics oscilloscope front end attenuator. So uh, maybe I should show you uh, the whole project first. So uh, in last video, several videos, I'm just show you uh, a separate part of this microscope. Okay, here is the microscope itself. I basically just get the column and the specimen chamber and nothing left. The whole structure is being made by myself, and the control panel is made by myself also the control circuit and the high voltage system and the power supply system. Okay, here is the detector power supply. uh, Here is the high voltage oil tank for the high voltage connection and the filament power transformer. Okay, here is the filament power transformer. Here is the current meter, which shows the filament current. Okay, here is a turbo molecular pump to get the high vacuum. Okay, here is the vacuum gauges. Okay, uh, here is the control panel, which is made by myself. Here is the high voltage power supply, negative 0 to 60,000 volts. And here is the several power supply. Here is the control box for the lens control system and the uh, deflection coil drive system and the scanning signal source. Okay, here shows the filament lifetime. Here is the filament current. Here is the acceleration voltage. Okay, now here is the system. Okay, whole bunch of power supplies and isolation boxes. Okay, basically this section uh, in a box, this section in a box, this section in a box. Okay, down here you can see much more details. Here is a box for the uh, scanning signal source or driver. Okay, here is a heatsink, is the scanning coil driver. Here is the lens coil system. So let me focus on the okay. Let me focus on the frame. Okay, set of light, and then you can see much more details of this gold coated tungsten wire. Okay, let me shut off the backlight and adjust the camera to zoom on the screen. Okay, here is a oscilloscope screen being used for the display, and it has a P7 long presence phosphor. Due to this phosphor, you can see the image details on a slow sweep mode. Okay, uh, so let me zoom in and trying to see some details. So this wire might be in 0.02 millimeters or 20 micron. Oh, 20 micron. Oh, okay, let me zoom in. Okay, now here you can see much more details on the surface of this wire. Let me zoom in a little bit. Okay, I might be just the focus a little bit, but uh, back zoom back into the real-time mode. So why is so flaky in real-time mode? It's because what I'm using is a very cheap STM32 and the internal deck don't get a quite much accuracy. Okay, so it got a pretty rough sawtooth wave output in real-time mode. It's slower, so when I'm using a slow mode, it can solve this problem. So let me zoom in a little bit. So you can see much more details. But for this, what you can see on the camera is not as clear as what I see directly on the screen. Maybe it's focused on the uh, grade of the tool, not the image back the grade. Okay, let me zoom in a little bit. Now here we can see much more details of the surface, the wire. Now we can see it's pretty rough on the surface, even though it's coated by gold. Um, okay, so this is in this scale, it's basically what I can get on this setup. So maybe in the future I can get it digitized and use a computer to control all of this. But in this step, I just going to try this system can be run well. Okay, might be run well in this stage. Okay, let me put on the light. Okay, thanks for watching. I hope you enjoy this video. I will see you in next video. Bye.